Hello, everyone. Welcome to another Open Cluster Management Community meeting. Today, we're super excited to have Isu to give us an introduction on Clusternet, an open source project that he has been working on. So, Isu, welcome to our community meeting. And whenever you're ready, please feel free to share your screen and start your presentation.
Okay, thanks. I'm glad to be here. And just share the screen. Oh, wait a minute. Hi, you guys can see the
Yep.
PowerPoint. Yeah. Hi guys, this is Dish. I have been with Kubernetes for more than 12 years, and I'm a top code contributor to Kubernetes. Now I work at Tencent. I'm very glad to be here to introduce Clusternet. Since this is a pretty new project, I'm going to just give you a brief introduction of Clusternet. For deep dive part, we could have another session for that. And this is my GitHub handle. So if you got any questions, feel free to ping me GitHub or Slack. So and please don't hesitate to interrupt me if you got any questions during the talk. This is today's agenda, and just some simple introductions here. First, I will just talk about what is Clusternet. Um, Clusternet comes from the combination word of cluster internet. So just as the name says, the goals of Clusternet is trying to help manage your clusters as easily as visiting the internet. No matter the clusters are running on a private cloud, hybrid cloud, or at the edge, Clusternet lets you manage or visit them all as if they were running locally. This also helps eliminate the need to jungle different environments for each cluster. Actually, we started this project since March this year, and we released our first version at May and open sourced at that time. Now we have got two release versions. You can check it out with this GitHub URL. And now Clusternet is multiple platforms supported, including some normal platforms. Before we move forward, I want to show you some notable features of Clusternet. Clusternet supports cluster registrations and fully management. That means you can fully manage your registered child clusters. And here we have two uh, concepts: parent cluster and child cluster. Just as the parent and the child cluster will try to register themselves to the parent cluster. You could visit, with the help of Clusternet, you could visit all your registered child clusters to configure or fully export. You now support using service account tokens, bootstrap tokens, and jersey certificates. And Clusternet also helps deploy and coordinate applications to child clusters. Now we only support Helm charts for other native Kubernetes resources and the third-party PRDs. We are still in developing, and the next release will be ready. And this is architecture of Clusternet. And Clusternet is quite simple. It consists of two components: Clusternet agent and Clusternet hub. For Clusternet agent, it runs at each child Kubernetes cluster. You could have multiple replicas for Clusternet agent. And the Clusternet hub is running at the parent cluster. Currently, we only support the single replica, but for the next few versions, we could support running multiple replicas for Clusternet hub. For Clusternet agents, it will try to suggest current cluster to the parent cluster and reports heartbeats of current child cluster, including current Kubernetes version, running platform, version status, ready status, etc. And it also helps to set up a WebSocket connection to the parent cluster. And the Clusternet hub will try to maintain all this long connection sessions. And the Clusternet hub runs, as you can see in the picture. Clusternet hub runs as an aggregate ApiServer that maintains multiple active WebSocket connections from Clusternet agent. And through this WebSocket connection, you could visit the child cluster directly, even if we could not direct visit the child cluster from the parent cluster. And the Clusternet hub will also try to create exclusive sets of resources for each child cluster, such as dedicated namespaces, service counts, and relative backdoors. And we will try to expose REST handler to proxy all the requests to the child cluster. This means you could manage all your clusters from the parent cluster. So that means you could also from the cluster B, the right part, from cluster A, which does the same as the parent cluster. And here we have some difficult design to enable the Outbreak visit. The kubectl used here is a combination of two kubectl. One is from the parent cluster, and another is from the child cluster. I will show the example of a kubectl later. This is an animation image to better illustrate what Clusternet is trying to solve. With the help of Clusternet, you could help break all the proxy, all the network connections from the clusters. You could visit any cluster that requested from the parent cluster. As you can see from the architecture, the Clusternet is quite lightweighted, and it runs as an add-on to on your current Kubernetes cluster. So it is very simple and easy to install. I'll just show you some the copy config that we used in the visit. Can you see this page?
We're looking at the Clusternet architecture page.
Yeah. So the copy config, I just talked about the copy config. The copy config is a little bit complicated, but it's native supported by the Kubernetes community. So we just use some special parts in the copy config settings. And the first change is you need to append a default URL to the original parent cluster. So this is some simple snippets to help you modify the changes. But if you know how to change it, it is very simple. You just need to append this part at the end of the original URL. This URL is the parent server endpoints. So this is the first part we need to change. And another part is the credentials. So the credentials used here is from child cluster. So currently support bootstrap tokens, subsequent tokens, and TLS certificates. And for the credential parts, you just scroll down and see here. So we just use the impersonate and user extras. Actually, the impersonate is not to impersonate this user to the child cluster. We just impersonate in the master cluster to
Are
have the
you
ability.
are you showing your terminal because we can only see the slides, but not your
What?
terminal.
Okay, so
Maybe you need to stop sharing and change the.
okay. And here you see this page,
Yeah.
Firefox. Right. Sorry for that. I just grew up to the first part. And so this is a quick config. Actually, this is a notable features of Clusternet, since we could use the copy config of the combination from parent cluster and child cluster to help you visit the child cluster directly from parent cluster. So the new copy config contains two parts. The first part is from the parent cluster. So what you need to do is to append this long URL to original parent cluster URL, cluster addresses. So these are some snippets to help you better modify the URL. But actually, if you know how to change it, it is quite simple. You just need to append this long string to at the end of the regional parent cluster endpoints. This is the original parent cluster endpoints, and you need to append the APIs, the GVK, the socket, and this ID. Actually, this ID is the globally unique ID for each cluster. Since the cluster agent during the registration, the cluster agent will try to set up generate a list, and we use this leads user ID as a cluster ID, so it is quite different and unique. And this is the sub resources proxy, and this is child cluster endpoints. Actually, could just append direct at the end of this cluster. Cluster is this. So what's the difference from these two UL is if you are just directly visiting this cluster. So this is the cluster UID. So you just put direct at the end of the UL. So, but if you want to visit another UL, not only the API child API server, so you just put the complete the address here. So this is the first part. We change the config server URL, and the next part is we change the credentials like users in the copy config. The copy config here we support several kinds of credentials like bootstrap tokens, service account tokens, and DIS certificates. And I just scroll down to the important part. This is the change we need to modify. Here we use the impersonate system anonymous. Actually, the impersonate here, we are not impersonate some rows to the child cluster. We just impersonate to the parent cluster that will have the ability to impersonate to use use extras. So this is just the short circuit in the parent cluster. So as we use this user to impersonate as Clusternet, so this is a special name we have defined when we deploy Clusternet using the Outbreak rules. And after that, we could use this use extras in our request and this part, you just need to update the tokens here. So after the API server forward the request to the Clusternet hub, as we run, sorry to screw up. As the Clusternet hub runs as an aggregate server, so when the user request forwarded from to the API server, the headers will be added with tokens and credentials. So the Clusternet hub will receive the credentials from the headers. So that's why we could have the ability to visit the child cluster. Let's scroll down here to the Outbreak.
And if I can jump in with just a quick question there to understand the authorization behavior.
Yeah.
In your example, you had a user
Right.
of Clusternet, and then you had the additional parameters. And what I was trying to understand is that referencing a service account named Clusternet on the child cluster, which is then doing user impersonation with a user token?
Yeah, actually, the impersonator here is purely in parent cluster, not in child cluster. That means we just use impersonator to this user. We use system anonymous as Clusternet. This is the user in parent cluster. So since this user has the ability to have the user extras.
So so in this case, the API request came in as the Clusternet user on the parent cluster, and then the additional user extra data was sent directly to the API server of the child, and it will authenticate with whatever user identity is associated with that token. Yeah,
correct.
Okay, thank you.
So actually, the tokens and all the certificates here, just as the page says, Clusternet doesn't care about those credentials at all. Pass them directly to child clusters.
Okay. And then maybe related, if you wanted, does Clusternet account for, let's say that you have a user identity on the parent, on the hub, and I have the user identity on the hub. When I was kind of looking through the RBAC, can I assign your user identity on the hub to only be allowed to talk to specific managed clusters, and my identity on the hub to only be allowed to talk to other managed clusters?
Yeah, this could be an alternative. So what we want to try to do is to have a center authentication in the parent cluster or in the hub. So then the hub will impersonate profile on the user to every child cluster, right?
Potentially, I think what I'm really trying to understand is how can you protect who can access those proxy API endpoints?
Yeah, of course. Actually, since we use the sub-resource here, sockets proxy, right? So you could limit or set some back rules for sockets proxy with some scripts. Yeah.
Okay.
Back. Have some RBAC. Yeah, you have bootstrap RBAC and hub RBAC. And bootstrap RBAC is quite important to let us have the rights to impersonate as Clusternet. This is the core part that we how we redirect the request to child cluster.
Okay,
so,
got it.
Yeah. So another part is about the socket proxy, and the socket proxy here. Yeah, this is the cluster for Clusternet hub. But for every registry cluster, we will generate a dedicated back for that cluster with some filters right here. So And this sockets are all every child cluster has has all the rights to visit the child cluster, but yeah, it could have some add-on limitations on the sockets proxy sub resource.
Okay, thank you very much.
And another notable features of Clusternet is it will try to help trust multiple clusters. And for other native resources, we are still in development. Let's show you how we deploy some charts. And these are some simple manifest Helm charts legends. And here we just need to define a Helm chart repo and tag namespace. And then you just need to have another relation of subscriptions. And here you could get some fees here. This could be kind Helm chart and have a subscribers here. So that means these subscribers will deploy this Helm charts. So these two samples, and you could have a Helm chart deployed to the subscribers. These subscribers actually are using level selectors to manage to matching the cluster ID. And this is a HR release. Since Helm use release to install every chart, so we just need to transform the subscription to several paths of Helm release and check every release status to the final status of every subscription. And after that, you could use Helm list with a specific namespace to show the current status of every Helm chart. This is a Helm chart part. These are all the notable features of Clusternet for now, and for the next few releases, we will support other normal Kubernetes or native Kubernetes resources like deployment, step sets, replica sets, etc., and use third-party CRDs.
Yes, does that mean that you are going to have an orchestration layer for the deployment that somehow you split the deployment to the child cluster?
Yeah, exactly.
I see. Another question about the Clusternet is because I think currently all the agents send a WebSocket connection back to the kube API server of the parent cluster. So, is there any scalability that you will consider? For example, if there are many clusters, will that impact the kube API server of parent cluster?
Yeah, it could be. We are going to run some benchmarks on the performance of Clusternet.
Hey, I also got a question about the scalabilities because first of all, thank you so much for sharing us the emerging project. And I think the network, the Clusternet is basically trying to solving the cluster network connectivity issues by introducing a aggregated API server, and which basically makes every packet, every data transferring between clusters flowing through the aggregated API server, which can be a scalability bottleneck. So especially for those data intensive cases where yeah, I think that will be a critical issue if it's for some data intensive cases. So is there any specific reason why you pick the while you are trying to solve the cluster network connectivity issues by the aggregated API server, instead of just flattening the networks. We just had the submarines months ago, which is just trying to flattening the cluster networks by solving some other, on the other hand, some tricky problems like conflicting IPs or all the other network issues.
One reason is that actually initially we designed Clusternet to solve some edge scenarios. That means you are running a cluster at the edge and there is no enough resources like the public IP addresses or the work activities. So you just need to reuse the existing visiting network to the parent cluster. So that's why we use aggregate API server to maintain all the active long-running WebSocket connections. And another reason is that we could solve many the management problems. And the performance here is quite critical. And actually, the current features of Clusternet, all the suggested usage of cluster is to help you better manage your clusters. That means you could use Clusternet to help you management that data. So, but for your other users, like you are using Clusternet help to visit another service, other cluster, so we are not suggesting you to do this. So you could have another VPN or a channel to help you solve the data plan here. So Clusternet is mainly to help you solve the management plan.
So, if I'm getting correctly, you are suggesting that the whole Clusternet solution is just aimed for providing a minimal solution for solving the connectivity issue between clusters. Is it right? Great. I think the bright side of the solution is that the entire solution is completely decoupled from the underlying data center networks. So it doesn't matter if the cluster is actually deployed in the data center or just on a laptop. As long as the connectivity between the hub and the child cluster is good, so every data can be transferred between the peer clusters successfully. I think this will be good for a meaningful transformation, but for some data-intensive cases like RPC microservices between different clusters, this will be kind of a scalability bottleneck. So you just said that to have a additional VPA approach to punch through the child clusters.
Right. Yeah.
So that makes sense. Thank you.
Min, just to kind of catch up with where you're at, is that observation about the bottleneck related specifically to the use of an aggregated API server, or are you thinking there's something else there, like when having a service that could scale out horizontally and still provide the proxy behavior, avoid the bottleneck that you're poking on?
But considering that there can be some long connections like watches, I don't know if there are watches between across the clusters. So services can be sometimes not that good at solving the load balancing issues for long connections. But if the aggregated API servers can scale horizontally, by a service, that will be good enough for solving the short running requests.
Okay. And maybe is it D or die? Apologies for the name pronunciation.
D.
Okay, thank you. Is it the case that that today the aggregated API server that's backing this service is able to scale out horizontally, or how does it work as of right now?
Currently, Clusternet Hub is running a single replica, and for next few versions, we could support multiple replicas for Clusternet Hub. So the scalability, the issue could be mitigate after that.
Okay. Okay.
It just reminds me of the how the API server network proxy under the Kubernetes SIG subproject. How does the another project solve the horizontal scalability issues? As far as I know, the API server network proxy, or AMP, is trying to solve the issue by having fixed replicas. So the every proxy API servers deployed in the hub cluster is running in fixed replicas. So every agent will trying to, well, first of all, when the agent is running in the beginning, it will fetch the number of the replicas of the proxy servers deployed in the hub clusters. So then the agents will be keep retrying through the services until it successfully handshaked with enough number of replicas of the proxy servers.
Yeah, so other replicas need to know the active sessions in other replicas.
Yeah, I think Clusternet can try to solve the issues similarly.
Yeah, we will do that.
That would be a. Thank you.
So I think another interesting thing might be like because there's multiple. I mean, there's a remote WebSocket, and I'm not sure whether will be controller actually watch the remote API servers by the WebSocket tunnel, and so what happens when a WebSocket disconnected temporarily? I mean, will that impact the controller to watch those requests? Oh,
The controller is running in child cluster?
I mean, the controller, I think the controller in the hub, actually, I'm not sure whether there's use cases like you will have a controller on the parent cluster that watch multiple API servers on the child cluster. So in that case, I'm quite interested in.
Oh, no.
Yeah.
Oh,
Okay.
I mean, such as one of the agents that is active with the cluster hub, and the controller is running in parent cluster. So the watch to the child cluster API server will be interrupted, right?
Yeah, I mean, will that be somehow reconnected, or when the connection is back? Oh, I mean, I'm not quite sure the behavior here. Like, if you really have a controller on parent that watch multiple API servers in a child cluster, and when the WebSocket disconnected temporarily and reconnect back, what will happen for those watch requests?
Actually, for the coverage features on Clusternet, we just using the leading collection. So that means we have 3 replicas here, but only one is working, right? But in the future, we are trying to change this to let every replica or cluster agent to connect to Clusternet Hub. So that means the Clusternet Hub will maintain several active sessions to the child cluster. So this will help solve the problem you just mentioned.
Okay, thank you.
Are there any other questions for Dee?
Yeah.
I want to ask a little bit more uncomfortable question. So obviously there are some overlapping between Clusternet and Open Cluster Management.
Yeah.
Yuzhang, do you want to talk a little bit about that? How maybe we can work together to avoid some duplicating work?
Yeah, that's some we actually have some previous discussion with Dee on that, and I think there are some possible options that we are looking at. For example, one possible option is that we could somehow distract, somehow use the open APIs in the open cluster management and use some part of the Clusternet to build a solution. For example, running Clusternet as an add-on in the open cluster management. There might be other options. I'm not sure whether Dee, would you like to share something?
Yeah, actually, we have some pre-discussions with Chill several days ago, and actually have some alternatives, but which one is the best or which kind of collaborations is still under discussed.
Yeah.
Thank you.
And if you have got any good proposals, so you could just let us know.
Great.
I think certainly having this capability within Open Cluster Management could be very useful, and having even the commonality of if it does make sense and if you're interested in working with Open Cluster Management to leverage the concepts are going to be similar, right? The Open Cluster Management defines a managed cluster idea, defines a subscription idea. There might be some different capability that you'd also benefit that may not be part of what was needed to get to a running form of Clusternet today. But as we try to integrate other open source capabilities in the market, whether that's integrations with Thanos or integrations with Submariner, having Clusternet being able to use that same core set of APIs might be beneficial in your own adoption of your own project, right? Because you might be able to use the same core concept for managed cluster, but also get integrations with networking or observability behavior or other things like that.
Yeah, of course.
Okay. Are there any other questions? If not, well, thank you so much, Disu, for introducing us to Clusternet. If there are no more questions, we can call it for a day. See you guys in 2 weeks. Thank you, everyone.
That's good. Thanks all.